Our next job is to draw the view on the iPad screen. That is, our animated view of the following words. The single window you see displayed on the iPad is an instance of the UI window class. The window is created at launch time by the UI kit loading it from the nib file, which we saw earlier, the main window.xib file. You add the views and controls to the window. In general, after you create the window object, that is, if you create it instead of having it done for you, you never really have to think about it again. Although your iPad app never creates more than one window at a time, iOS can support additional windows on top of your window. The view is a rectangular area on the screen on top of a window. The content view is that portion of data and controls that appear below the status bar and the navigation bar if you have one. Now, views and subviews create a view hierarchy, and there are two ways of looking at it: visually, which is how the user perceives it, and hierarchically, which is how you structure it. Looking at it visually, the window is at the base of this hierarchy with a content view on top of it, and the content view is like a transparent view that fills the window's content rectangle. The content view displays information and also allows the user to interact with the app using, of course, user interface items such as the text field and button that we're going to put in. And each one of those is really a specialized kind of view, but the way you create it is different. Now, once the content view is there as a subview, any views that you add to that content view become subviews of the content view. And then those views, which are subviews of the content view, become super views of any views that are added to them. Or think of it this way: a view can have one and only one super view, and either none or a whole bunch of subviews. Or just think about it as a container. A super view contains its subviews. Well, of course, the view must manage its subviews, as well as resize itself with respect to its superviews. Fortunately, much of what the view must do is already coded for you. But the view hierarchy plays a key role in both drawing and event handling. When a window is sent a message to display itself, the window asks its subview to render itself first. If that view has a subview, it asks its subview to render itself first, and then go down the structural hierarchy until the last subview is reached. It then renders itself and returns to its caller, which renders itself and back to the top. Now, you create or modify a view hierarchy whenever you add a view to another view with Interface Builder. The UIKit framework automatically handles all the relationships associated with the view hierarchy. Now, remember our design patterns? We've already used the model view controller and delegation patterns, and I showed you the info and done buttons in the My World app for the iPhone using the target action pattern. And of course, we're going to put them in again in the iPad version, MyPad World. In an iPad app world, view objects are responsible for the view functionality in the modal view controller architecture. View controllers implement the controller component of the model view controller design pattern. The controller objects contain the code that connects the app view's objects to its model objects. They provide the data to the view. Whenever the view needs to display something, the view controller goes out and gets what the view needs from the model. Similarly, view controllers respond to controls in your content view and may do things like tell the model to update its data, such as when the user adds or changes text in a text field. Also, the target action pattern plays a role. A view controller is often the target object that responds to the on-screen controls. The target action mechanism is what enables the view controller to be aware of any changes in the view, which can then be transmitted to the model. And of course, another way to add behavior involves using the delegation pattern, which lets you customize an object's behavior without having to subclass it. You're basically forcing another object to do the first object's work. For example, the delegation design pattern is used at application startup to invoke the application did finish launching with options method, which gives you a place to do your own app-specific initialization. All you have to do is add your code to that method. Basically, you're using a behavior-rich object supplied by the framework as is, and you're putting your code for program-specific behavior in a separate delegate object. And when a request is made of the framework object, the method of the delegate that implements that program-specific behavior is automatically called. Now, yet another way to add behavior is using block objects. Blocks are like traditional C functions in that they're small, self-contained units of code. They can even be passed in as arguments of methods and functions and then used when they're needed to do some work. The block object design pattern is similar to delegation, but it's more event-driven. in that it lets you create methods or functions that you can pass to other methods or functions, and then execute it as needed. We'll be doing a little bit of the managed memory model as well, that pattern, a little bit later in this. Now let's take a look at what we've already set up in our view controller. Now here we are at MyPad World, and we've selected MyPad World View Controller. And we've already put in our synthesize statements to create our accessor methods. And we've also marked off sections of the code so that it's easy to find things, such as our memory management section, our view lifecycle, animation, controls, etc. We're going to go to the view lifecycle section, which is right here. Now let's take a look at the viewDidLoad method. So the app is loaded into memory and viewDidLoad is called. We've already set up our timer with a scheduled time interval of 0.5 seconds that will send to the target, which is this controller, the onTimer message. So what this does is creates and returns a new NSTimer object and schedules it on the current run loop. The timer waits for 0.5 seconds and then fires, sending the message onTimer to the target object, which is the view controller. Since it's using the current run loop, it's really piggybacking off the loop that's already established in the template with UI application. We don't have to create a run loop. We can simply create a method that handles the message that we receive from the timer. We also use the viewDidLoad method to set up our NS string and allocate it for falling words, and to initialize it with the string peace on earth. And we also initialize speed to be 10, and that's for the purpose of testing our view code. Later, we will put in our user preferences code. Now, connecting the timer to the actual drawing of the display is the onTimer method. Right now, we have a placeholder method for that. Now, we're going to actually type in our animation code in the onTimer method, very similar to what we did on the iPhone, with a few differences in order to take advantage of the much larger iPad screen. But first, we're going to do a UI label for the falling image view. We're going to allocate that UI label and initialize it with a frame that we make with a CG rect make. That frame is going to be 0 for the X, 0 for the Y, 400 for width and height. Now we immediately get a warning and it says it's an unused variable. Well, we will be using it, so Xcode, you should pay attention. Watch how we use it. So we're going to assign the falling image view text to falling words. Simple enough. We're going to deal now with the falling image view text color. And for this, we want to use the UI color object, and we want to set it to magenta, which will be readable against that image we used of the windsurfer for our background screen. And we also want to set the falling image view font to use the UI font object, system font of size, and we'll make it a larger size than for the iPhone. We need the falling image view background color to be a UI color object set to clear color, so it doesn't compete with the background image that we have for the window. And to deal with maybe a long string of text, if the user types that in, we're going to set the falling image view adjusts font size to fit width to be yes, so that the image view adjusts to the font size to fit a much longer string. Now we're going to do a different thing that we did in the iPhone app. We're going to randomize the starting and ending point of the label that we're doing here, the falling image view. We're going to create an integer, start X. We're going to use the random function to generate a pseudo-random number between 1 and 300. One too many parentheses there. Our integer endX will also be a random function generating a random number between 0 and 300 in both cases. The random function uses a nonlinear additive feedback random number generator. Now it has a default table size of 31 long integers and returns successive pseudo-random numbers in the range from 0 to 2,147,483,647. So we've done the starting ending point. We want to do one more for the speed. We're going to call it random speed and set that to a nice formula involving the random function between 1 and 100. We're going to put in the +1 here. speed. Okay, we take random speed out of it. So now we're ready to create a CGRect structure for the location and dimensions of the rectangle of our falling image view. And we're going to define really the starting point and the ending point for the animation by doing so. So we use a CGRect, create a start image frame, which is really the falling image view frame. Do another CGRect for the end image frame, which is also the size of the falling image frame. Our start image frame origin point, we're going to use a CG point make to set that. CG point make, now we're going to use our start X and minus 100 as our point of origin here. We're going to do the same thing with the end image frames. We're going to use CGRect make to make that happen at end X, the bottom of the frame itself, by saying self view frame size height and 400. So now that we've set up the start image frame and the end image frame, we're going to set the falling image view frame into position at the start image frame. We're also setting the falling image view alpha to be 0.75. The alpha, of course, is the receiver's alpha value, its opacity. So here we've set it up with start image frame and end image frame so that it's possible at any time in the future to go back in here and adjust these values without having to change the animation block, as you'll see. Finally, we're going to add the subview, and we do that to the view. Self view, add subview, falling image view. So now that we've added the subview, all we need to do now is use the block animation method, which we'll put in down here. Let's scroll down a little bit so we can see what we're doing. In the block animation method, animate with duration. We're going to use a UI view, which defines a rectangular area on the screen so that we can have animation running through it. In this case, it'll be the entire screen. Animate with duration. And this time we're going to use random speed, since we have a randomizer for the speed. Our animations are as follows. UI view, we set animation delegate self. So this is the delegate, the view controller itself. Our falling image view frame at the end of the animation should be at end image frame. And that's really all we need there. But we have to now include completion. Our completion code, which is right here, we click on the word completion out here and it automatically creates our two brackets and gives us a place to put code right here. And here we're going to put falling image view. We're going to remove it from the super view. We're also going to release falling image view right here at the end of the animation block. Now that we've had the completion code, we're done with the block and we're in. Let me explain what just happened here. The UI view class provides common methods you can use to create all types of views. In this particular code, it's used for a block of animation. The block-based animation method, animate with duration, which is available only with iOS version 4 and newer, greatly simplifies creating an animation. Here we are with one method call. We specify the animation and its options. Before iOS version 4, we had to use begin animations context and commit animations class methods to mark the beginning and ending of an animation. But here we can animate with duration, specify the speed, and specify the animation itself, the end frame, right inside the block. The code changes the rectangle's starting coordinates from start image frame to end image frame. The animate with duration method also includes the completion code, and we use that to remove the falling image view from the super view, which also removes it from its window and from the responder chain. And then we use release, which, by the way, is an instance method of the NS Auto Release Pool class. We use release to release falling image view. And it's something to remember. You own any object you create with Alloc, and we allocated falling image view with Alloc, which means we're responsible for releasing it when we're done with it. And that's a nice segue into the next thing we need to learn about, which is how to free up memory.